Hello there and welcome back to the channel. Today is the second video in my Prowler Rover series, and in this one I'm going to take you through unboxing what's included and me building the rover, and I filmed that on my GoPro, and whilst I have speeded it up I give you guys an overview of what I had to do to get it built and working. I also fitted the motor controller and I'll talk about that in some more detail as well, and at the end of the video I'm going to show you this up and running and out and about in its initial testing, and I've done that with my Tyrannus remote controller and a standard RC receiver. Now in future videos I'm going to be taking you through setting this up with the Cube Purple Autopilot with GPS and Ardurover as well, but today we're going to concentrate on the basics of getting the main rover up and running. So let's get on with it. Okay, so to give you a walkthrough of the unboxing and build, what you have is your 4 tyres with the foam inserts, you get your fixing kit, your 4 motors, the wheels, as well as the 2 ABS pre-cut plates. The motors themselves are made with the gearboxes pre-fitted on, ready to go, and you simply unwrap them and they are ready to be used. Now, as I've said, the gearbox is pre-mounted and it is as simple as soldering the wires on the back and it's ready to go. The wheels are 2 in each pack, and you simply prop them inside the tyre as you go and then they're ready to be fitted. Now, you've got a top and bottom mounting plate. Now, you can choose which one is top and which one is bottom yourself. It's all down to the kind of build you're going to use. And again, within the kit, you get all of the fixings and mounting plates that you need for putting the unit together, which includes the aluminium plates that go between the top and the bottom plate, as well as the fixings for the motors and the fixings for connecting the wheels to the shafts. So the first thing we're going to do is mount the plate fixings on, and there are 4 of these, and these are the brackets that hold the motor as well as the frame together, and there's one of these that goes on each corner, and you simply bolt them on with the 2 bolts on either side, and then you are ready to mount the motors onto them. Now, what I would say is when you get the motors at this stage, once you've got it like that, now is the best point to put the motors on, because you don't want to put the motors in place when you've got the top plate on. It will make your life a lot harder. So what I'm doing is offering the motors up, and then there is simply 4 screws that go into each one. Now, I am adding a little bit of Loctite onto each screw, which I've got on a little thing up in the top left hand corner, and I'm simply rotating the motors to the best position that I preferred them in. Now, having done this once, I'd have actually rotated them a bit differently had I known, because there is an open section on the back of the motors where there is a position where some debris could get in. However, I am going to talk about that in later videos because I've actually printed some covers for this rover as well. So once you've got the motors fitted, the next thing to do then is to put the wheels and the tyres on. Now, what you've got is these little mounting units that go onto the shafts of the motors, and then the wheels bolt onto these, so it's almost like a hub basically, and then you simply screw these in place onto each motor, and they simply have a grub screw that goes over the shaft, and then you tighten it up onto each one and it goes in place, and then it has the wheel nut that goes through the center. Now, the tires do have this foam thing in the middle, so you will need to mess around with them a little bit as you get them on. It doesn't take too long to get them in place, but it does take a little bit of movement on the edge of the tire, because what I was finding was the foam was actually getting in the way and the tire wasn't fitting on properly. So once you've got the motor in place and then the tyres ready to fit, you simply pop it on, put the nut through the centre, and it's ready to go, as easy as that. Now, the next job to do is look at wiring the motors, because you want to do it at this stage here whilst everything is open within the unit. So the first thing I did was cut lengths of wire to the right length. Now, the recommendation was to use wire of around 12 AWG. Unfortunately, I didn't have any, so I ended up using 16. However, I've done the calculations and it shouldn't actually be an issue. And to be honest, even 12 has plenty of headroom for my use. And again, I was simply just soldering up each one at a time, putting the tails in place, and then making sure that I had everything ready to go once I'd actually got them all fitted. And the nice thing about doing it this way is you don't have to worry about having everything in the way once you've put that top plate on, as I'm doing now. Now, for me, I decided to put the solid bit of the plate on the bottom, but you can see those 4 grooves as I mentioned, and you can just see the motor gaps through them as well. And this was the bit that I was talking about where there is the possibility of debris getting in, but I will talk about that a little bit more later in the video. So the next thing I needed to do was to fit the motor controller. Now, I have chosen to go with the 2x32 Sabertooth motor controller from Dimension Engineering, and I will talk about that in a little bit more detail later on in this video. Now, the first thing I had to do was decide where it was going to go, and I thought about mounting it in the middle, but it could be in the way. So what I decided to do is mount it in the back corner. Once I got it in place with 4 posts, the job then was simply to wire it up. And again, I will cover that a little bit. Now, you will notice I connected a battery up then, and that was just to make sure that I did have the rotation of the motors correct as I was wiring it up. And actually, I still got one of them wrong whilst doing it this way. So I would suggest checking it before you do it. Once I had all the motor wires in place, it was simply a job of putting cable ties, keeping everything nice and tidy, putting it down in the frame out the way, and it leaves me then enough space. As mentioned, I decided to go with the Sabertooth dual 32 amp DC motor driver from Dimension Engineering. Now, the reason I went for this one was as follows. The first is these controllers get fantastic feedback from the users. They are absolutely built solid and they are packed with features. This controller not only works on standard RC input, but it will take a digital input as well as an analog and computer-based input too, and you can configure this to do pretty much anything you want it to do. Now, it is the dual 32 amp, which means it will do up to 64 amp peak per channel. There are 2 channels, but I will wire the motors left side and right side. Now, this controller has a huge amount of features. It has built-in battery monitoring. It is regenerative, so it will actually put power back into the battery when the motors are spinning down. You can actually set Expo and all of the inputs for the RC, and it actually has a computer app that you can plug in via the onboard USB port and configure everything, including the battery protection. You can tell it how many cells it's got, but it will also detect that for you as well if you want to. But it allows you to do all of the configuration via the app. There is also a switch block on board as well, which is a set of dip switches that allow you to change preset features of the controller as well, and I'll talk about that a little bit later on in the video. But overall, the Sabertooth 32 is absolutely packed with features, and for me it was the overall best option to go for. It's also absolutely solidly built and has got built-in cooling as part of the unit as well, which means you don't have to worry about it overheating too much. It's got that built-in heatsink which actually surrounds the whole unit, so once you bolt it in place, just make sure you do fit it where it will get some airflow and you don't have to worry about any thermal issues then. Okay, so just to take a closer look at this. Now, I've already got the motor driver installed and it is all pre-wired up, but what I'm going to do is take you through looking at it a little bit closer. Now, before we do that, I just want to explain that I've got the motors pre-wired. The left-hand side, as I'm looking at it, are wired together, and the right-hand side motors are wired together as well. Now, before you do this, you do want to make sure that you get the rotation correct. So what I would suggest doing is putting a battery on your motors, rotating them and getting the left side and the right side both going in the ways you want them, and pair up the 2 positive and negative terminals on each one so you know which way round to mount them on the controller itself. Okay, so taking a closer look at the motor controller, as I've said, I've actually already fitted it and it is all pre-wired. Now, all of the large connections up this side here are the main motor and power inputs, and they are laid out as follows. The first 2 is for motor 1, the center 2 is battery positive and battery negative, and the third pair is motor 2. And as I mentioned at the start, for motor 1, I've got my 2 left-hand ones connected. For motor 2, I've got my 2 right-hand motors connected. And then to the center 2, I've simply got my battery plus and negative. That goes straight to an XT60 to be using with my LiPo. Now, as I did say, make sure you do pair your motors up correctly, that you got your 2 left ones and your 2 right ones rotating the right direction, because it is a bit of a pain to change once you've done this. So for the wiring on that side, we're pretty much straightforward as that. Moving down to the bottom end, you have your main signal inputs. What you've got down here is this one here is a negative terminal, and next to that is positive 5 volt, and that is a up to 1 amp output to allow you to power an RC receiver or anything else that you may want to power from the unit. However, do be aware that it is only up to 1 amp maximum, and I would suggest that you do have some additional power regulation in place if you're going to do anything like a Pixhawk or a cube like I'm doing, because that in itself may not be enough. Next to there, you've then got your signal inputs for your RC or your analog, and that is on 1 and 2. And then next to that, we've got some additional inputs, and then you've got some additional power outputs over here as well, over here in the corner, which are used for connecting to resistors, depending on if you're using it with, say, braked motors, resistors, or things like that. Next to this, we've then got a micro USB port, and this is used for A, updating the firmware, but B, also changing a lot of the settings on the unit, because the Sabertooth has a whole host of menu options available, and you can plug it into the PC or Mac software and change them. And I will show that at the end of this video, because there is some stuff there you need to be aware of. Finally, you've got the block of switches, and what these do is change the setup for the motor controller depending on what input you're going to use. Now, there are tons of options for this, and these switches are actually dynamic. They change depending on what feature you've set. Now for me, I've set this into RC mode because I'm using it with an X8R receiver from my Taranis at the moment, and that mode is allowing it to take PWM in via the 2 screws, and I'm allowed to control it via that. However, you do need to configure that as such, and to do that is as follows. You need to set switch 1 to off and switch 2 to on. That tells the board that you're going to use RC input. If you do not set switch 1 to off and you power it up, even with an RC connected, you will find it will suddenly jump to life and try to run away on you. And that is because it is picking up the analog input instead of the PWM input. So it is important to use it with an RC on PWM, switch 1 off, switch 2 on. The next switch you need to be aware of is switch 3, and that determines what the power input is, whether it is a battery or a power supply, because you can use this unit on both. If you're using it on a power supply, it turns off all of the low voltage protection to stop you destroying your battery. However, if you're going to use it with a battery, you actually want that low power protection to be in place, and it will simply cut power to the motors when the cell voltage reaches a certain level. So to turn the battery power protection on, you need to set switch 3 to off. Now, by default, the settings for this are set at 3 volt off the top of my head and LiPo. Now you can change that within the settings because it will automatically detect how many cells your battery has, and when you plug your battery in, the LED will actually flash to show you that, to say how many cells it has detected. And just to demo that, I'm just going to connect up a 3S LiPo, and I don't know if you can see, if I actually tilt it up, you can see that the LED is flashing 3 times, and that is telling me that it has picked up a 3S LiPo. However, one thing to be aware of, as I mentioned, was that its lowest voltage, because it determines the cell voltage based on the pack voltage, is actually set at 3 volt as standard, and that is too low for a LiPo. So if you're going to use the low power feature, you do need to connect it to the USB, and make sure you change your lowest cell voltage to something like 3.7 volts on a LiPo, or if you're using another battery type, whatever the lowest recommended voltage is for that. Now, as I did say, it automatically was set at LiPo for me, but you can change the type of battery for lead acid and things like that in the settings as well. The next switch to be aware of is switch 4, and switch 4 decides whether it's independent or mixed channels. At the moment, I've now got it on mixed, which means input 1 will be forward and reverse, and input 2 will be steering. However, if you were to set it as independent, input 1 would be left-hand motors, for instance, and input 2 would be right-hand motors. So you would have that skid steering kind of control rather than the mixed motor control. Now, as I'm using it with a standard receiver on my Taranis, I'm currently using it on mixed, and that's the best setting to go with in that case. The next switch is switch 5, and that is expo or linear, and the basics of that are just the same as a normal RC. Within the unit, it has exponential built in for you already. If you want to use that, you can turn it on by setting switch 5 to off, and that uses the expo curve. Otherwise, if you set it to on, it turns the expo curve off and it will just track the PWM input as it comes from the RC. Now again, you can change this expo curve in the software as well when you connect it up to your PC. I've currently got it turned on because it was quicker for me to do that than mess around with the expo in my RC, and the curve that was preset was pretty much bang on for my testing. The final switch is switch 6, and that is currently set to on, and this is for TX or multi-controller input. What they mean by this is whether you want your input PWM endpoints to be fixed. If you set switch 6 to off, it will have 1000 as full reverse, 1500 as center, and 2000 as full forward. However, if you set switch 6 to on, it will automatically configure the endpoints when you first boot the unit up and every time you boot the unit up. So for instance, if you're using it with a remote controller with a self-centering throttle, it would simply set whatever position they're in as the center and then max forward and back as the maximum forward and back speed. However, there is something to be aware of this. If you were to power this on with either one of your sticks out of place, so it wasn't in the correct position, or you were to accidentally be holding a stick or using a non-centered throttle, if you were to power it on with the throttle which is full forward on minimum, for instance, you would have no reverse, you would just have full forward. So it is something to be aware of, that if you are going to use it in TX mode, that automatically sets the center position and endpoints. You could get trouble if you haven't got self-centering sticks, and in that situation you want to switch it to off and just set your endpoints on your RC to 1000 for full reverse, 1500 for center, and then 2000 for full forward. Finally, over here you have these other 4 connections. As I mentioned earlier, we've got analog inputs and serial inputs here, and these can actually be used alongside these inputs for a second input, or you can use them for other features as well. You've then got the power outputs on the side, again configurable by the software depending on what you want to do with it. If you've got motors that have brakes or you've got motors that have solenoids, you can actually power them off that as well. The one really nice thing about the Sabertooth controller is it has a huge amount of options and a massive amount of capability depending on what you want to do on it. Now, as I've said, I have fitted it and it is fairly straightforward. I've got it screwed down in place with some airflow underneath it as well. So if I put that there, you can see I can get the screwdriver underneath, so I know it's not going to overheat. I have put it up tight in the corner and I do get some airflow through the heatsink on the sides as well. Next, we're going to take a quick look over the software just so you can see some of the options that are available to you on it as well. Okay, before I finish this one up, I just want to quickly show you the software for the controller. And this is called Describe, and you can download it directly from their website. So what I'm going to do now is connect to the controller, and this will allow me to connect straight to the unit. And then it will download the settings that are already loaded on board. And you have various options available within this software. Now, as I mentioned earlier, that it does have the switches on the top. However, these are for predetermined functions. However, you have a lot more options available once you do connect it to the software. Now, on the main screen, you've got the general and you've got the mapping available for the RC input. You've got the startup delay, the minimum and maximum voltage options for your battery, as well as your battery type. You can tell it to auto detect, as well as the battery cell voltages as well. Then you've got under analog, this is where you can set the options for the analog input pins that I showed you earlier on the front of the unit, and it allows you to set these from 0 to 5 volts if you're going to control it from a multi-controller or an Arduino or something like that. Then you've got the RC settings, and here you're able to set the actual maximum and minimum values, as well as the curves you've got available as well for each input. So you've got S1 and S2 as well as A2 as well. So it gives you the option to be able to either physically set the options for the top and bottom end of the servo inputs, or actually have it as automatic. You've got the option for fixed or automatic calibration, joystick self-center, or whether you've got the saved options too. Moving across to serial and USB, this is where you connect it and show the settings for connecting it again to a multi-controller over USB rather than the analog inputs. The motor output options allows you to set the current limiting as the physical amount, the current limiting smoothing, the dead band, as well as the ramping options and the battery compensation features as well. The final two options is the power outputs, which allow you to set it for things like voltage clamp, brakes or controlled output, depending on what your motors have got. And then you've got the user mode options at the end, which allow you to just change a couple of the other settings as well. And it's everything set up in one place, and it allows you to actually set multiple user profiles within the unit too. You've also got some other options at the top, which are connect and download. You've got upload, because once you've changed the settings, you'll need to upload them back. You've also got device monitor as well, which allows you to monitor how the motor controller is actually behaving in use. And it brings up the settings for that one then, and it shows you the inputs live, as well as shows you everything that is happening. And this is really handy for able to diagnose what is going on with the unit when you're using it, and if you are having problems, because you'll be able to then track and see what's going on directly within the unit. However, overall, that's pretty much it. And finally, this is the Rover in action. Now, this is it simply set up with my Taranis RC, and I've got a 3S battery in there. And the idea of this was just to give it a proper shakedown, make sure the motors are doing everything I would expect them to do, as well as make sure the motor controller works as expected. And the idea of this is to make sure it's all good before I fit that cube purple and get Ardurover on board. Now, I have to say, I was loving taking this out and about for the day. It was absolutely flying round, going over anything I threw at it, and it gave me no problems whatsoever. Now, it is interesting, it is quite fast when it's out and about, but the tyres on this do give a huge amount of grip as well, and when you do have it in that skid steering, you can actually hear them gripping the tarmac quite heavily, and I can see me going through a few sets of tyres on this, so you probably do want to stock up when you get this thing out and about. However, overall, I have to say, really impressed with it so far, and looking forward to getting the autopilot on board. And that was it for this video. As I've said, in future videos, we're going to be taking you through setting it up with the Cube Autopilot, with the purple one, as well as setting it up with Ardurover as well, getting GPS running. And I've been doing a lot of 3D printing on brackets, and I've got some lights to fit onto it as well. And I'll be taking you through that as time goes on. Now, this is a winter project for me. It is going to be quite a slow one. I've got about 9 different projects on the go at the same time at the moment, so I'm trying to work through them a little bit on each one, but I will continue to keep you guys updated on this one as time goes on. That's it for this video. If you've liked what you've seen, please do subscribe to the channel, and I will do another one again soon. Please do subscribe to the channel and check out all of the other videos we have available. They are also split into playlists to help you easily find the ones that are relevant to you. If you would like to support the channel, please check out the links that are in the description for each video. You will find the links for the products we've been talking about, and it's only by you guys purchasing via these links that allows us to keep making videos and buy products to talk about in the future. Please also check us out and follow us on all of the social media platforms such as Twitter, Instagram and Facebook. We're beginning to build these accounts up, and whilst it is early days, I would appreciate it if you would like, share and follow us on these platforms. Finally, please also check out my website, www.madrc.com. Now, this is somewhere that we've been putting some of our blog posts and things like that over the last couple of years. So if you're interested in having a look, please do go check it out. That is it. Please do click that subscribe button. Thank you very much, and I will do another video again soon.